Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over another example problem of how you can use conversion factors to help you find the answer to a problem. In this problem we've got another flask that's filled up with water, and then you're going to put some lead into the flask, fill that up with water, and we're going to find what the density of lead is. So let's get into this. So here we have a small stoppered flask, weighs 34.20 grams when it's empty and 83.75 grams when it's filled with water at 20 degrees Celsius. When a 95.60 piece of lead is placed into the same flask, the flask is filled to its full remaining capacity with water at 20 degrees Celsius, and the total mass, this should be only 1L. The total mass is 170.93 grams. What is the density of the lead in grams per centimeter cubed? And they were given the density of water at 20 degrees is 0.9982 grams per milliliter. So how do you begin this problem? Well, first think about density. We want to know what the density of lead is, and so we have to know how to calculate density. So density, if you recall, is the mass divided by the volume. So if you know the mass of the substance and you know the volume, just divide the mass by the volume and you get the density. Easy peasy lemon squeezy, as they say. So do we know the mass of lead? Yeah, they're giving us the mass of lead over here. So when a 95.60 gram piece of lead is put into the flask, so we've got the mass, right? So the mass is going to be 95.60 grams. So now all we need to do is find the volume. We don't know the volume. They didn't give that to us. But we can figure out the volume of the lead based on the information they're giving us. So if we knew the total volume of the flask and we knew the total volume of the water that was occupying the flask along with the lead, then we could subtract those two and we would end up with the remaining volume that's taken up by just the lead, right? And then we could use that in our calculation. So let's go ahead and try to do that. So how do we find the volume of the flask when it's empty? What's the total volume of the flask? Well, we can figure that out by figuring out what the volume of the water is that fills up the flask. So here we're told that the flask when it's empty is 34.0 or 20 grams, but when we fill up to the brim with water, we get the mass of 83.75 grams. So we can find the mass of the water in the flask. If we know the mass of the water in the flask that's at 20 degrees Celsius, they gave us the density. So we can use the density to convert the mass in grams to milliliters. And so we got the volume of the flask that's taken up by the water. So let's go ahead and do that. So we got to find the mass of the water in the flask. So we're going to take the 83.75 grams. This is the mass with the flask and the water. We're going to subtract out just the mass of the empty flask, which is 34.20 grams. And when we subtract those two, we get 49.55. 49.55 grams. So now we know the mass of the water that fills up the empty flask. And so we can use our density now to convert that to volume of water, which is also going to be the volume of the flask. So now we take this and we're going to use this as a conversion factor. So since we have grams here on the top, we're going to put the grams on the bottom. So 0.99, oops. Sorry about that. So it's 0.9982 grams and 1 milliliter on top. So grams cancels out. We have milliliters. Now all we need to do is calculate. And when we calculate that, we get, hold on a second, 49.6393. So 49.6393. I think that's enough. I think I have another digit. 5. So 5 milliliters of water. So we got to keep track of sig figs. So let's go back to our subtraction. The rule when you're subtracting or adding measurements is that your answer should have the same number of decimal places as the least number of decimal places in the measurements you're adding or subtracting. So here we have 2 decimal places. Here you have 2. So that means our answer should have 2 since 2 is the least number. And we have 2. So that's good. Now, when we're multiplying and dividing, the answer we get here should have the same number of sig figs as the least number of sig figs we are multiplying and dividing. So here I have 4 sig figs. Here I have 4. So my answer is only allowed to have 4 sig figs. So I have 1, 2, 3, 4. So I stop at the 3. Now, however, I don't want to round here. You always want to keep at least 1 extra digit after the last sig fig. So I can keep the 9 and drop the 3 and the 5 and then continue with my calculation. You want to do that if you're continuing to use this as a in a further calculation, which we are going to do in this problem here. Okay, so now I have the volume of the empty flask. So now what I need to do is, now I take the flask that's filled with the lead and the water, and I want to calculate the volume of the water that's occupying the flask along with the lead. So you do the exact same calculation. So in this case, the total amount of mass is that going to be 170.93 grams. And I'm going to subtract out the mass of the empty flask along with the mass of the lead. And what's left over is the mass of the water that's occupying the rest of the space. So I'm going to subtract out 34.20 grams. And then I'm going to subtract out the, where is it? The 95.60 grams of the lead. So that's 95.60 grams. And when I subtract those two out, I get 4113. So 4113 grams of water. And again, because I'm subtracting here, my answer should have the same number of decimal places as the least number of decimal places. But you'll notice they all have 2 decimal places. So I should have 2 decimal places, and I do. So this is good. We'll keep that number. Now I want to convert that to volume using the same density. So I'm going to go ahead and use this again. I'm going to convert this to volume to find out the volume occupied by that amount of water. So here, I'm going to use this conversion factor again. So 1 milliliter goes on top. 0.9982 grams goes on the bottom. Grams cancels out. I have milliliters. And when I calculate this out, I get, where is it? 41.20416. So 41.20416 milliliters. Okay, so again, here I have 4 sig figs, 4 sig figs. So my answer should have the same number of sig figs as the least number, which is 4. So 1, 2, 3, 4. So I'm going to underline that one. Again, I should keep at least one extra digit if I'm going to use this in a further calculation, and I am going to use this. Okay, so now I have milliliters. So this is the volume of the empty flask. This is the volume of the space left over with the lead in the flask. So if I want to find the volume of the lead, I subtract out the volume of the water in the flask from the total volume of the flask. And when I do that, so I'm going to do that by 49.639. I keep one extra digit, and then I'm going to subtract from that 41.204. So I'm going to keep one extra digit, and when I do that, I get, what's my answer? I subtract those two, and I get 8.4351. So 8.435. I think that's it. So here, again, since I have 2 decimal places here, again, my significant digits end at the line. So I have 1, 2 decimal places here, and again, I have 1, 2 decimal places there. And when I subtract, my answer should have 2 decimal places. So here's the second decimal place. I'm keeping the 5 again because I need to use this to do my further calculation. I now have the volume. Oh, sorry, this is in milliliters, right? Milliliters and milliliters, and this is in milliliters. So this is the volume of the lead in the flask. So now I have the volume, so now I can plug it in to find the density of the lead. So now I'm going to go ahead and plug everything in. The mass is 95.60 grams. And then this is 8.435. Again, I'm going to put the line under the 3 to remind myself that this is my last significant digit. So now, oh, and by the way, 1 milliliter is the same as 1 centimeter cubed. So if you're wondering, well, it's asking for centimeters cubed. Well, 1 milliliter is equal to 1 centimeter cubed. So this is the same as centimeter cubed. So this would be equal to 8.435 centimeters cubed. So I can change this to centimeters cubed. And when I calculate my answer, I get 11.3 grams per centimeter cubed. And that is the final answer. Why? Because when you multiply and divide, your answer should have the same number of sig figs as the least number of sig figs. So here I have 1, 2, 3, 4. That 0 is significant, so I have 4 sig figs here. Remember, the line here indicates that's my last sig fig. So I have 1, 2, 3. So the 3 is the lesser number. So that means my answer should have 3 sig figs. So 11.3 grams per centimeter cubed is the answer to this problem. So that's it for this video. I hope you enjoyed the video. If you did, then please like, share this video, hit that like button, subscribe to the channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a particular question or problem you need help with, put that down below. I would love to help you with that. Thanks for joining me, and have a great day.